Now we'll see about LED, light emitting diode. It is just like a normal PN junction diode, which is connected in forward bias. So in forward bias, current is flowing through the diode. At the junction, hole and electron recombination takes place. Due to this, some energy is released in the form of photon, light. That light comes out from the junction through a window, which is a transparent window provided near the junction. In forward bias, it gives output light, and in reverse bias, current flowing through the diode is zero. So no light comes outside, no photon come outside. The circuit symbol of LED is shown in this figure. Two arrow marks which are going outside shows that on passing current in forward bias, light comes comes outside from the junction. If you take a graph between power eliminated by the LED or output power and current flowing through the diode. If current flowing through the diode increases, power increases, but beyond certain value, power output become constant. Even current increases, it become constant. These LEDs they use in power indicators in different electronic devices, and these are used too in display systems like LED TV. Now let's see about a photodiode. What is photodiode means? It is just like a normal PN junction diode only, but which is connected in reverse bias condition. They provide a small glass window near the junction to allow light fall on the junction. And diode is in reverse bias means we know depletion layer width is increases and almost zero current is flowing. So when we get current means further electron hole recombination takes place, then only it is possible. Here what happened, and through this glass window light is illuminated on the junction. That energy of light is converted into electron and hole. So actually what happened, energy will be absorbed by the atoms. The covalent bond between the atoms in semiconductor breaks and they form free electron and hole. Whatever the hole here forms near the junction, that is dripped towards to p side, and electron is dripped towards to n side because of battery polarities. That means some current is set in the circuit. Whenever light fall on the junction, electron hole pair generated and current is set in the circuit. When more number of photons are incident, we get more current. So here circuit symbol of photodiode given like normal diode only, but arrow mark shows that light is fall on the junction. And the graph of this photodiode is just like a reverse bias condition PN junction diode characteristics, VI characteristics. We know negative potential, that's why we are taking potential on negative x-axis. We get a negative current, reverse current, that's why we are taking on negative y-axis. But this current is very small, that's why we can take in microamps. Actually, for a given intensity, we get one graph, suppose I1 less intensity, I2 means more intensity, and I3. So I4 is highest intensity is there, thus we get a maximum negative current we are getting. Where they use these photodiodes, whatever the power generated here, that is not useful, and because it is having very less amount of current, microamps only. That's why they use this type of photodiodes and as a light sensors, and to measure the brightness of light, they use as a light meters also. Now we'll see about solar cell. It is normal PN junction diode only, but unbiased diode. Using a resistor, they short circuit P-type and N-type materials. So whenever light is incident on the junction, of course here also they provide a glass window near the junction. When light incident on that hole and electron is forming near the junction, And again, those two are recombined through the external resistance. Some current is set, that is IL is set in the circuit. Suppose if this resistance is zero, that means what you call short circuit, then huge current is flowing, huge current, that current what you call I short circuit. Their potential is zero, because short circuit means potential across the diode is zero. Suppose if you take here, if you increase the resistance across the diode R, then what happen? Current decreases and potential across the diode increases. So that potential what we call potential in open circuit. Current becomes zero and potential become maximum. And where they use this means solar cell. They use in satellites to generate, to convert light energy into electrical energy. And some type of instrument like calculators, they use this type of solar cells.